Hi, it's Joe here at Measurement Solutions. In this video, I'm going to run through a very quick scan of this part using our Creaform HandySCAN Black Elite. So we've opened our instance of VX Elements. I'm going to hit Next to start the scan, and we're going to be able to start setting up our scan parameters. So we've got the resolution here. I'm going to put this down to 0.5mm resolution. We've got options to remove isolated patches automatically. We've got our target diameter. In this instance, we've got 6mm diameter target set up already, and our shutter speed, so we can adjust this for scanning light or dark areas depending on what we're scanning. I'm going to leave it at this setting. That'll be fine for what we're scanning today. So I'm going to hit Start Scan, pick up our scanner, hit our LED on the back, and we're going to start to pick up some scan data. Just going to zoom out a little bit to give us a better picture of what we're scanning here. And as we work around the part, we refer to this as similar to digital spray painting. So we're moving around the part, making sure we can pick up as much data as we possibly can. Where the areas of hatching are green, that means we're a good distance away, and we're picking up data at 1.5 million points per second. Now, if we get too close, the hatching area is going to turn red, so is the LED on the back of the scanner. We know we're too close. As we get further away, we're going to turn blue, and we know we're too far away and need to get a little bit closer. So we're just going to work our way over the part, picking up as much data as we can. We can't overscan the part. The software is going to be constantly writing and rewriting, so we're not laying up lots and lots of scan data on top of each other. And the beauty of having targets on the part means that we can spin it around. If we can't get to the back side of the part, we can just spin the part around and continue seamlessly scanning the other side of the part. Just going to work around this for a couple more seconds just to pick up a few more data points, and then we're going to pause this scan and we're going to flip it over to scan the inside of the part. So I think we've got enough data on this side. Let's hit pause, go back into the software, stop the scan. The first thing we're going to need to do is get rid of this table that's underneath the part. So I'm just going to hit Remove Background. It's going to automatically detect this table. Let's hit Create to create a clipping plane to get rid of that table. I'm also going to select the main body that we've just scanned here and remove any isolated patches. So we're just going to delete anything that's not connected to that main body. It's just going to delete any little bits of noise and other bits that the table didn't clip out for us. Okay, so we've got the outside surface. Now I'm going to flip it over and start scanning the inside of the part. So let's add a scan. It's OK. We can start this second scan. Again, pick up the scanner, hit the button on the back, and start to pick up the data on the inside of the part. Again, we want to keep the hatches green as much as possible to make sure that we're picking up all the data that we need. We've got a couple of areas here with some slightly deeper pockets, which are a bit more difficult to get into with the hatching that we've got on the laser at the moment. But if we zoom into a particularly difficult area, we can use the single laser feature. So if we double click on the back, we're now just going to one single laser line. That's going to enable us to get into these deeper pockets much easier. Pick up a lot more data with this single laser line. So we can use this to go into deeper holes and deeper pockets, pick up data that we wouldn't otherwise be able to if we had our hatching turned on. Okay, so I'm going to go back to our hatch mode and carry on working around the inside of the part to pick up a little bit more data on the inside. Again, we've got target, so we can just spin the part around on the table. If there's an area that we're really struggling to get to, we can even pick the part up and carry on scanning it with it in our hands. Sometimes a bit easier to be able to work around the part while we've got hold of it. Once we're happy that we've got enough scan data here, we can just set the part down, stop the scan, and start the process of removing the table and then merging these two scans together. At the moment we've got two separate scans, one of the outside, one of the inside. So we're going to have to firstly align these two scans together and then merge them. So the first thing to do is remove the background of that scan that we just created. We can do that very quickly with the remove background command in VX Elements. Let's get rid of these few little bits of noise that we've picked up as well. So we're going to delete anything apart from that main surface that I've just selected. So we're going to align these two parts together, and we're going to do that with a target best fit. So we've got a couple of common targets that we scanned on both sides of the part. We're going to use those to align the two scans together. So we're going to fix scan 1, make scan 2 mobile, preview what that looks like. We've done a pretty good job there of aligning those two scans together. So I'm going to hit OK, and now we've got a merge of those two scans. So we're going to merge these scans together. At the moment they're just two aligned separate scan datas. Let's merge the scans together and hit accept. And now we're going to be able to export our final mesh. So we've got our resolution set. We set it to 0.5 millimeter to start with. We can now bump it up to 1 millimeter or reduce it to 0.25, 0.1. The raw data has all been captured. It's just the resolution is just the resolution that we output that data in. So I'm going to leave this at 0.5. And I'm going to send this scan into VX Model. This is where we're going to start to be able to build step features to go into our CAD software. So we can see the level of detail that we've picked up on the scan here. We can go in and see the detail that we've picked up on the logo. There are a few holes where we didn't quite capture all the way through the hole, just because we did a very quick scan of the top surface. If we spin this around, you can see we've done a great job here using that single laser line to get into this hole depth, something that's really difficult with the hatch lines. Okay, so from here we can start fixing up the mesh. If we want to export a watertight mesh, we would just go fill holes to start with. We can automatically fill in all of the holes that have been left just where we didn't quite capture the full data when we were scanning. We can go fill holes, clean mesh, and then we're going to create a watertight mesh that can either go out for 3D printing or into the next part of the process that we want to run through. If we hit apply here, we're just going to remove any isolated patches, spikes, narrow triangles to create a nice watertight mesh. So if we're happy with what we've created here, we're just going to hit OK. Have a quick look around the part. You can see that it's now a fully watertight mesh, ready to export out to NTOP, to Fusion 360, whatever we want to do with the model next. Okay, that's all I was going to show you today. If you've got any questions, please feel free to give me a shout. Cheers.